Right, let's see how this goes.
We have made our attempt. Alright, so how many of you are here for the first time? Just a quick check. Alright, excellent. So one of the group, we don't have folks here. Alright, so let's jump in into today's session. I did not get the markers picked up. Someone grab the markers. Oh, you have them? Okay. Yeah. Excellent. This one cover.
That's only some. I got it. What ones are big ones?
Big one, bigger one, the bigger one.
I can.
Yeah, the big chapter,
These ones are
usable two for the back.
Oh, yeah.
That's why I can do.
Okay.
Yeah, big ones are great. Thank you so much. Alright. So, let's get started. But before we get started, how many of you have actually prepared for the session? Just curious to see if you've taken a look at the questions.
See two of them.
All right, nice. That's good. Let me open up the meetup page and we'll get started. One sec. Now, hey, just grab a spot. Go. All right. So the first question is deck of cards. So can someone explain what the question is? What is asked? What is the equation?
It says design the data structure for generic deck of cards. Explain how you would subclass the data structure for class.
Not particularly fond of the way that's phrased, but let's go with it. All right, so how many of you have actually not played cards? Like a typical deck of cards? Yes, no? Not at all? So one of the things that we want to do for these questions, for these type of questions, especially the ones that involve like some kind of prior knowledge, right? There's an expectation that you know what a deck of cards are, what they contain. It might make more sense to just walk through what the shared understanding is. So what is a deck of cards? You've got cards, and typically the card essentially has like a face value, right? And how many cards are there in a deck? Are you sure? 64, 52, any other numbers?
That's true in a tarot deck or a pinochle deck.
Plain card deck, like the regular plain cards.
54.
Depends on the
52 is
game.
not quite right for one reason why. We've got jokers.
No, not for black. Not for
blackjack. But a deck of cards has other things as well beyond that. So there may be
Is there any game where you actually use jokers?
gin, rummy, a bunch of games.
Correct.
So at least when I go to Costco, get a pack of the bicycle poker deck, I usually see it has like essentially 53 or 54 or like 54, 55 cards. It's essentially what it has is there is a suit, which is essentially like the hearts, spade, diamonds, and clubs. Again?
Sweet suit. SUIT.
Thank you. And then it has like value, which is essentially, it starts with the A, and then it goes 2, 3, all the way up to 10. And then after that, you have essentially more, which is Jack, Queen, and King. So that essentially gets you 13 cards of each suit. And that gives you essentially 52 cards, right? And besides that, you also have essentially 2 jokers. And usually you have like one card which just kind of talks about like, hey, this is bicycle deck, with quality, guarantee, and all that stuff. The advantage that I've seen at least is that if I lose a card at any point of time, I can just go write that if I lose like the ace of spades, then I can just go to this card, just write ace of spades on it, and then I can just use it to salvage the deck. So not that it specifically has any value, but there's like an extra card as well, which I think is of no practical value in most games. So typical games actually do use these 52 cards. And there are a few games where the jokers are actually used. There are games where the jokers actually have special rules, special roles. There's one of the games, if you're a card player, there is apparently a game called Landlord, where the jokers have like very specific meaning. Like on my Emirates flight, I usually go to the game section, and then they have you play, and actually they have like a special rule for like we call it the gold dragon and the silver dragon. Yes, that's actually totally cool.
If you really want to be like.
So the thing is that for jacks, right? So for the jack, queen, and the king, what they do is that they actually have different imagery for represent the jacks and the queen and the king. The jacks, there are actually two of them are two-eyed jacks and two of them are one-eyed jacks. Essentially, of the four jacks, right? Heart, spades, dice, the clubs. I don't know which is which, but essentially two of them are one-eyed jacks and two of them are two-eyed jacks. In games like Sequence, you actually use the two-eyed jacks. Like one-eyed jacks actually remove, and two-eyed jacks the wild card or something like that. There's like rules there.
You did poker sometimes.
So is it? For poker, apparently there's that you can do as well. And for king, each of the kings is apparently there's like a trivia there. Each of the king is based on some specific thing. Some, I think the king of diamonds has no mustache.
Well, some people put their sword through their head.
Yep. There's like different. So some oddities around how this is there. Ace of spades is something that's special. It's usually very ornate, very decorative. Apparently, back in those days when cards were taxed, Ace of spades was essentially not included as a pack of the cards, but you get that only after you pay tax. And so they usually make that harder to replicate, so they have like the ornate Ace of spades. So that is all that. So now, anyway, enough of trivia. So let's back to the design, right? So getting to know what the deck of cards is actually important. It's good to know what are the different categorizations, what are the different classes, and things like that. Now that we know this, right? Before we get into this, the goal of what is the goal of an interview question? Which is talking about like system design interview question, object-oriented design. So we are actually here talking about design. So what kind of design is this question? Clearly O, right? So in O design, what do you want to talk about? What are the things that you want to make sure that you communicate to the interviewer that I know what I'm talking about? Inheritance, all right.
Polymorphism.
Not bad, that's good. Abstraction. What is the other one?
Interface.
Usually around the behavior and abstraction interface actually falls in between. What else? Separation of this. These are the fundamental ones, but there are like more angles of it. Like separation of concerns kind of comes under the abstraction concept, but you're trying to make sure that different entities have like a unique role. And in certain cases, like data hiding or making sure that your responsibility of each object or each class or subclass is essentially its encapsulation. So fundamentally these four. So I don't know how you do it in an interview, but your goal is to kind of make sure that walk through that somewhere in the middle of your interview, just walk through it, have I touched all these four notes. If you haven't, make sure that you're actually injecting that in your solution. Just 3 columns, not 4? Where would you actually put abstraction otherwise? Follow. Okay? Let me mark it out. I usually have kept it separately usually because it's like you're talking about specific type of abstraction. That's how I've done it. But I can see that. I can see how you can like abstraction is either abstraction in terms of data or abstraction in terms of behavior, or it's some kind of like an inheritance.
Yeah, I've heard it referred to.
Yeah, as you said, 3 pillars of object-oriented design could be these 3. Abstraction is a concept which actually just lends itself to it. So that's what we want to do here, right? So now, if we want to do that, how do we do that with the deck of cards? So let's talk about deck of cards. Let's assume that we're not thinking about poker here, or blackjack here. So let's only this. Now, how do we deal with it?
Let's start with the lowest level.
Yeah. All right. So you would want. So let's talk about the objects that you want to use, right? So you have card. Card is an object. What about the card deck?
Collection of cards.
Collection, array, vector, list, queue, stack. What do you use?
It's actually
Yeah,
the queue lends itself pretty well, but if the queue is not sortable or not shuffleable,
Maybe map of suits. Map of suits.
So a deck is a class of its own. Card is a class of its own, right? The card represents what? An individual card. What does a card contain? What values does the card contain?
it's the value and the suit.
Yeah.
How do you define what is Joker a card?
Yeah.
So what is the value?
you introduce jokers.
We can go for any kind of a wide value, like a star or something.
What is the suit?
Suit probably
For Joker.
J.
doesn't belong.
Doesn't matter.
So don't do that in an interview. Because if I were to be building a game of cards or like a mobile phone app or something and define an object, I might most likely define it the way you say. I'm just going to call it suit. I'm going to call this like Joker. I'm going to call, you know what, I'm going to just cheat and say that Joker is the suit itself. And then I'm going to call this like Ace Joker or something like that. You know, I can cheat and you can always bend the rules a little bit to make it go. But in an interview, you might want to be a little bit more curious than that. So what would you do?
That's
So if there is like a super class card, then I would have all the cards inherited from the super class, and separately I would have these extra cards, the Joker and the extra card inherited again from the super class.
So card, in my opinion, would essentially be an abstract card. Essentially.
I don't think so. I would never do that.
Why?
The card is very low level thing. It should be almost a structure. You have almost no.
So if I were to, the reason why I say that is that why would the deck's behavior should not depend upon the card. If I have a deck of tarot cards or something, I can still shuffle it the same way. I can still deal it the same way. I can still cut it the same way. I'm just thinking, in my opinion, at least, I'm looking at the deck as more of a collection of cards, and the cards could be anything. It could be picture cards, it could be picture, it could be word list, it could be flash cards, it could be anything.
Like you're saying that
You could get the enum. I like that. So enum versus inheritance is a good question.
But if you use an enum, you're again stuck with the same problem, right? The Joker, you don't know how to.
Yeah. So you will use enum anyways at a lower level. You could use the extra fake suit to kind of represent the Joker, but instead, what I would actually recommend is actually. So let's just go with the flow, and then we'll come back and maybe question whether it makes sense, right? So I would think about it as an abstract card, and essentially a card could be of multiple types, and I'm kind of thinking special card or something like that in this case, and that has essentially some kind of an identifier which represents whether it's a Joker or it's an extra card or something like that.
Yeah.
And I will have what you typically call as playing card or regular card. So this is my proposal. Feel free to disagree. And here the playing card contains, as we talked about, it will contain the suit, it will contain the value. And what is the data type of suit? String?
suits. Enum.
String?
Enum.
it should be an equal.
Char?
Enum.
Enum, totally, because the suit is actually essentially a limited set of items. So totally, the enum, which represents the hearts, spades, diamonds, and clubs, is probably what I would do. Okay, totally makes sense. Now, what about the value?
I would split.
King?
Mine.
No.
You should split it into two. You should have the int is the value. The value is an int because you're always going to need the numeric value. Then there's like a display value or a display base or whatever you want to call it. Return a string, which is like king, queen,
This can be stored in a
Basically,
separate
go
map.
with an integer and have an extra method which takes care of this way.
Yes, correct.
Which maps the numbers to whatever.
But would you do it that way or would you do it the other way, where you have to actually have an enum and then you deal with the interpretation later?
I would save it in the compact form as an integer, and then like use the map for integer to string or whatever.
Pure O and practical O are like different things. So, funny as it may be, but in practical, if I were to be implementing a card game, I would probably put it as it. But if I were if I were doing this for an interview, what would we do? Not necessarily. Tarot card is very not in a playing card. In a playing card, this essentially only contains A through K. That's it. No questions asked. Right? The one reason why I would, from an argument, why I would actually not I don't like the fact that it's actually A through K is what is the order of the cards? In typical, is A's in the bottom or A's in the top? Is A's score 1 or is it left? It depends on the game, right? And there are games where essentially it's I don't know if you play the game of like 29, it's pretty popular in India, where the ordering of the cards essentially is Jack is the best, 9 goes next, then it's essentially Ace, King, Ace, 10, King, Queen, and then 8 and 7, something like that. Why? No freaking clue. That's the order in which the cards are, and the cards below that are not used. Like the 6 through 2 are not used in that type of game. So now you have a rank order which is different from what is commonly used in various cases. So my push would be here to say that do not actually ascribe an implied order by using an 8. That would be my argument that I would actually talk about. There is, again, these are for object-oriented design, and for most of the design questions, there is no right answer. There is no wrong. These are all you're trying to make a case, and in a typical work setting, what do? You come up with an idea, your peer comes up with an idea, somebody else comes up with an idea, and then you talk through it, and more likely than not, you decide to go with one option and then deal with it, right? So here, in this particular scenario, I would actually prefer not using an int. I would actually use an enum and have the ace through king as specifically enums, and let it go. Because the thing is that from an ordering standpoint, like how do I actually arrange them? I need to have something that kind of interprets this, and the interpretation of the playing card order is actually a function of not the playing card, but the game that you're trying to do. Because the game should have some kind of a logic that gets the playing card and decides which is better than which, and that could change. Like for example, if you have trying to think of a game where this works, but there are games where you actually are supposed to always do better than what is on the table. So if I put a 5, you're supposed to put a 6 on top of it, or you have to do equal or better, or something like that. Right? More, right? Okay. So that's what it is. But then there are special rules which actually says, but if you have 3 of hearts, you can put it anytime, or something like that. So there, the rules of and that 3 of hearts could change, because once 3 of hearts is used, now it becomes 3 of spades or something like that. So when that happens, the interpretation of the order could also be dynamic, and it could be runtime. I'm kind of making up the rules as I go here, but for a hypothetical game, if that were to be the scenario, the interpretation is not intrinsic to the playing card. It's kind of where I'm getting. So what are we talking about here? We are actually specifically looking at what is the data, right? How are we trying to encapsulate the data into each element, and that is what we're trying to get. So that is the playing card. Then we're also talking about behavior. We're trying to talk about what is the behavior of each of these cards, like what can we do. And in general, an object would encapsulate both. It will have data, a concept, and it also have some kind of a behavior concept. But in this case, this probably I am looking at a card as just a data holder. It's not. There's no behavior to the card. The card does not do anything in and of itself. The way I see it is, the deck will have the behavior. The card will have just data. It's how I'm seeing it right now.
That's what I'm saying.
Yeah, it's actually not an object, but it's more like a struct. In Java terms, I don't think there's a difference, but in few languages there are some differences. But even there, I think the lines have been blurred.
But struct typically doesn't have by convention. It doesn't have methods.
Yep.
It's strict by convention.
Okay. So that gets us so far with this, right? Any challenges on the playing card?
One thing I would say is the important thing, if you're going to have your subclass there, your superclass, then you need to have a deck of playing cards. My concern would be that if I have to build a deck, then I have to construct different types of cards for the deck. My deck's going to have to be able to handle any type of card. And so I think problems.
So why would your card not be able to handle an abstract card? Like, let's talk about the behavior of the card. Got a chair there. And there's more chairs in the front.
Because if your deck can handle any type of card,
sorry, go ahead.
I have to think about it, but if the deck can handle any type of card, then you can't make any assumptions about the deck.
Which is actually brilliant. Then your deck is actually more generic. Right? So let's talk about it, right? So what do you want to do? So we want to have a deck, right? So let's talk about deck. What does a deck contain?
It's a collection.
Collection, list, stack, queue.
I think, like I said, I think I made it a queue at first, but see, a queue is very natural for the deck because you can only deal from one end.
So dealing is just a behavior of the thing, right? You could actually, there are games where you can actually take a card and shove it back into the deck. And there are things where you can actually cut a deck. And those are all behaviors that are potentially allowed. And if that be the case, so how you model the deck actually entirely depends on what are the behaviors that you do, right? So a few things that we know of, like, just in very raw terms, a deck of cards to me actually just looks like one card on top of another, and we just have like a bunch of cards just like stuck with each other. That's it, right? That's all it is. So it's essentially as it says, it's just a stack of cards, right? Stack as in just aligned on top of each other, not the data structure stack. All right. So all it is just like I'm going to call it a bunch of cards. Okay. Most common behavior that you see in a deck is essentially taking the top card, because that's what you do, which is essentially you deal one card. That's a very common behavior that you have, right? What else?
Shuffle.
Then you have shuffle. Okay. What else?
I guess you can cut it.
Let's now that we talked about cut a few times, let's actually say cut. Right? What else? What is that?
That's a property of the game.
Is it a property of the deck or is it a property of the game? Like, arranging a card. So there are a few games like Duplicate Bridge, where you're expected to actually arrange and organize the card deck in a very specific way. Right? Because I have two identical sets of decks, so you shuffle one deck and then you arrange the other deck identical to the first deck. So the idea in games like specifically in Bridge, right, is that depending on how the cards are dealt, of course there's an advantage, right? I mean, it is the luck of draw, so it means that if I give you a set of cards, you can do better. In Duplicate Bridge, what they do is that they make two sets of teams play the same game, and then they actually get if you do better than your mirror image, then you get more points. If you do poorer than your mirror image, one of them will get more points, one of them will get less points based on that. And for that particular scenario, you have to set up the deck of cards in a specific way. So there has to be like a way to clone it.
Right, so there should be a constructor. I made two constructors. Mm-hmm. One that gives you a deck just in, I don't know if I can call it constructor.
Clone is like, I'm just talking about as a property of like, this is what I need to do. Like, I need to be able to generate an arbitrary deck. Not really an arbitrary deck, but a deck which is actually
for testing purposes too as well.
For testing purposes as well, I would need that. And if I also have concepts of like save games, I need to be able to reconstruct the state of the deck at any point of time. Right? So I need to be able to like not necessarily clone, but sort of like generate a deck in a specific order. Right? I need to do that.
So I have two constructors. I have one constructor where it takes the deck, takes an existing array, and then one constructor an auto shuffle option that says give me a shuffle deck. Get the deck, shuffle it, keep it.
Okay?
I mean, some games have more than one deck, so maybe
yes,
decks allow other decks to be.
Fantastic question. So some games allow more than one deck. What does that? What does that mean? Do you have two decks, or do you have like just 104 cards?
You can
But it is essentially a deck.
Same.
It's a deck of six. It's like essentially a deck of 6 sets of cards.
Whatever the rule set is for that game, it's just multiplied by how many.
Yeah, because the shuffle is different. You can shuffle all 6 decks at the same time. So technically, yes, if you want to consider multiple decks, it changes the whole thing.
Why is shuffling different?
So you shuffle. So assuming it's 10 decks, not 6, it's easier to do the math. Then you have 520 cards to go with. The shuffle is actually all the 520 shuffled at once,
And you have to shuffle them once.
as opposed to 52 shuffling each 52 independently and then just concatenating them. That's not what it is. Right? That's a different behavior than shuffling all the 520 cards together.
You could have like, if you have 10 deuces, 6 stacks, you can have all. You should be able to have all 10.
All of them together. There should be a distinct possibility of all the
Yeah.
10 coming together at one shot. Like that has to happen, which will not happen if you independently shuffle and then attach. So,
More about the 104 cases.
okay. So, fantastic. Because there are games where there are actually different types of cards which are used. One of the games, again, is like Battle Line. It's a fantastic game. It's one of the classic, like awesome two-player games. There are not that many great two-player games that we have, but Battle Line actually has 2 sets of cards. It's not, you cannot play Battle Line with regular sets of cards. It has like, there's a power card separately, which essentially gives you all the wild cards and jokers and something else that modifies the rule. And then there is a set of cards, which is essentially the troop cards, which are very similar to your suits and numbers. So it has like 6 suits and it has 13 cards, but then that's different from the power card. So you may have 2 decks, but that's not the function of the deck, but that's the function of the game. Right? In general, if I were to look at poker as a poker, not poker, but blackjack as a game, then I'm looking at 6 decks of cards. I would take 6 sets of a classic standard poker deck, but in my mind, that is essentially 1 deck of 52 times 6 cards.
Right. You could just treat it as one deck.
It is just 1 deck of 52 times 6 cards and 300.
What loss that card has
And then there will be essentially 6 instances of ace of spades, 6 instances of that, and that's one, right? So you just go. That's how I would consider it. So if I did that, then it's just still 1 deck. Then all the other properties are true, right? I can still read a bunch of cards. I can still treat it as a dealing of cards. I can still shuffle. I can still cut. I can still go. It's the property of the game to figure out what the ordering of the cards are, right? So then I would also have some sort of like a game which is separate, but I don't know if the game is a good abstraction level. Because the games are so divergent in so many scenarios that I struggle to. I mean, a game will just be like an abstract placeholder game. You have nothing in it.
I don't think there'd be anything on top.
Well, if you look at like a game of cards, right? If you have that, then it's logical that you have like 1 or more decks. It's logical that you have like 1 or more players. Then there's usually a concept of a turn, but then that breaks down because not all games are turn-based.
That's all your game. That's your game engine. Your game engine should have a game class for that game, but I don't know if you have a generic.
I don't think, to me, when I look at all the games I know, I think there are multiple games where not all games are turn by turn. There are games where you actually you slam at the same time. So if you do that, then it violates the turn by turn principle. There is no ordering of what it is. It's like the quick draw, whoever draws first actually plays. There's a lot of different variations of the game. I mean, if you're a game, like card fan or a game fan, you probably see a lot of those.
One question. So if for this purpose, like Baccarat or something, that there are multiple decks. So is this an acceptable solution where you have the interface or something like that, which has a shuffle method, and then the game will definitely have a list of decks, and it can basically implement interface and override the shuffle method.
Just to repeat what you said, you're saying that would you actually look for, if you have multiple decks, would you actually look at the game handling the deck, but having a shuffle as an interface that can be implemented and then we deal with that? The challenge with that, right, is that I think I have concerns specifically around like the encapsulation of behavior and encapsulation of the data specifically. So grab a chat.
I think shuffle is a property of that.
I think
It
so.
doesn't matter what game you're playing. Cards.
Yeah. The cards are specifically, and I don't think shuffle is a property of the game unless the game actually kind of forces a shuffle. Right? If there is a game, for example, which actually insists on using a standard poker deck and insists on shuffling the number cards different from the kings, queens, and jacks, or something like that. Or it insists that the suits be shuffled independently and then concatenated. Right? If you had, I'm just making up these weird rules. If that were to be like a separate game, right, where it's just still one deck, right? And the way it works is that you shuffle all the suits separately, and then you concatenate them, and then you start playing. And the draw is the same. You still deal one card at a time, which is the top of the card, and so on. If you did that, now what's happening is that you cannot use the default shuffle that is there. So what do you do in that particular case? In that case, what you might want to do is, you might want to think about it as, either I have to create a special deck which can actually implement or figure out this thing, or I can implement the shuffle externally and then use this generate mechanism to generate the card. So I'm not using the shuffle anymore, which is by default provided by the particular object. And the reason why I'm doing the shuffle the way that is that most of my games need that. So the one of the fundamental benefits of object-oriented programming is reuse. So why I have implemented it this way is because most of the games that I know of, most of the games I think of, if I build it as a library of cards and library of algorithms that deal with it, it will work fantastic. And for most of the games. But it will fail for this weird game that we just made up, and that's perfectly fine. That happens, and when that happens, what we do is we need to have, so the thing there is that we need to have enough extensibility in play so that you should be able to override the sorting capability or the shuffling capability. And in order for you to do that, you should be able to, like having like an out, such as the cloning of the deck or generate, which is a good idea for testing anyways, to do that. What about access to any like card end? Can I look at?
No, looking at
Are you sure?
In the list, there's abstracted class or computer class or interface.
I haven't got the list yet. So I'm just looking at the properties at this point. So my first goal right now in this process is to go figure out what are the things you can do with the deck. Let's start with that, because once we figure all of that out, then we can figure out what data structure actually makes sense, right? So we've just talked about having a bunch of cards, so we didn't talk about whether it's a list or whatever it is. Then we know that we need to be able to take the first card, deal the first card reasonably efficiently, and then we need to be able to shuffle internally, and the shuffle essentially will randomize it, is all we are saying. There are special shuffle rules that we have for the hypothetical game we just made up. We may have a concept of cutting a deck. What does a cut do? So a cut makes a single deck into two decks. Is that what I'm hearing? Into two decks?
It's a form of shuffling.
It's just a form of shuffling.
Right.
Then how is that relevant? Why need a cut? If you split it into two decks, I think I have a case.
Yeah, you have to do a cut, but I don't know how you specify your cut.
A cut is mostly a way, in typical terms, the cut is just a way to make sure that I'm not like shuffling in a weird way. So I offer you to cut, so that way you, since you are also having an input into the cutting process, it's fairly certain that I'm not gaming this. So that is mostly for that. So if I were to take a cut in that particular sense of like just taking the top half of the pile and moving it to the bottom half or something at an arbitrary location, may not make too much sense in a typical deck on a computer path, in a software system. However, what I had in mind when I started cut was like in a game of, I think we used to call it money, is what we do is you take a deck, you kind of cut it into arbitrarily like two equivalent halves, and you give it to the other person, and then you just start playing. So essentially, it's kind of dealing half the cards to the other person and whatnot. You could implement that with just a deal, and just say that I'm just dealing 50% or like nearly 50% of cards to you. Cut is just a convenience function for me, because in that game of money, it doesn't really make a difference whether you have like 26 cards or 30 cards, because it's totally random. So the fact that you have 45 cards, you may still lose because of how the cards actually turn out. And there's really not a whole lot of advantage that you get with having too many cards. And the game is just a lot more lopsided if you have too fewer cards, so that's why you keep it even. But anyway, that's it. So in fact, I think I'm going to on second class I'm going to kill cut because I don't see value. So
Yeah, I think you were talking about a form of dealing where you separate the cards.
correct, but that you can emulate using deal. Right?
Yeah,
Then I can just deal roughly half the cards. Even if you want to emulate that half deal thing where it's not like a 26-26 split, but you're trying to deal half and half or something like that, nearly half, right? You can still use deal with a random number and then just decide to deal, on a probability basis. Whatever, I'm going to deal a card to you and a card to you, and then we'll figure out who gets the card is randomized using a random variable. You can do that as a part of the game.
I think it's not cut, but we have to take an integer, which is factor. Some way to think of some type of rate.
Or there are a bunch of ways of actually implementing them, but that should be a function of the game, not a deck. That cutting is a property of the game because the game decides that the implementing I need to cut the deck or I need to divide the contents of the deck into two different players. To me, is a game function, not a card.
But I guess I'll update your reg, and the game should not be updated. That's the problem.
Cut may not go into the game. There's a few more things that we are not kind of talking about. I think you mentioned one. One was you talked about a bunch of cards, right? One of the properties that you might want to expose is the size of the deck. The size, the number of cards that's there. Because there are games which actually depend on that to do different things. Like, for example, in the game of, I think Rummy is one of the examples, where you have a discard pile, and then you have a deck, which is a closed deck. If the number of cards in the closed deck is actually less than the number of players playing, then what you do is that you take the discard pile, and then you shuffle it back into the deck. So you can do that. And in order for you to do that, you need to be able to know the size of the deck. The game needs to know the size of the deck. That's all. It's the size, not the exact locations or the needed.
The size, are you saying size of cards? The size left?
The number of cards left on the. I'm assuming you're already thinking of an array, in which case the size is everything. But I'm thinking more abstract because the collection, the size is just left. How do you deal with discard? In the game of Rummy, the discard pile, what is it?
Another deck in the game.
It may or may not be another deck, depending on the game. In Rummy, you can only access the topmost card in the discard pile. So the discard pile behaves like a stack of cards. So and there is no shuffle property there. I can't shuffle the discard pile, so I don't need it to be a deck. It can actually be a stack of cards in that case. It doesn't have any other intrinsic property, and it doesn't have any reusable property per se, where I think. There are games where you can actually go through the deck of cards, through the discard pile, and pick a card of your choosing. You could do that if you want. Now, in that particular case, I need access to every card in the discard pile. So, for that particular game, I would implement it more like a list or something where I can access the top card. But I also have like the special ability to go through inspecting all the cards. So there are like few different ways in which it can work. So I would implement a discard pile more like a pretty simple stack of cards as opposed to using deck, because none of the properties that we have here are applicable. Possibly the generate might be applicable if you want to test certain things. The generate might be applicable if you want to save the game state and restart. Like if I were to be playing a game of Rummy with like 10 people, and then we just leave, go, come back after a day, and then continue playing, I want to repeat everything, right? I want to replicate your hand, I want to replicate the deck, I want to replicate the discard pile, I want to replicate all of that. So in order for me to do that, I need to be able to generate that stack at will, based on whatever the save game state is. Yes.
Yes, that's the question.
One of the things that we're trying to, by going over this process repeatedly, what we're actually getting to is we are clearly separating the game rules from the properties of the deck. And the fun thing here is that the deck properties are those abstracted from like shuffling. Is that a game function or is that a deck function? So shuffling is like, if you look at the game saying, hey, you shuffle a deck and then you do this. That's what you would say. So shuffling, the when to shuffle is actually a game function. Right? And most games that we know of require a shuffle function. And a shuffle function is entirely an action that can be performed by the deck in isolation without needing any further inputs. in most cases. Hence, it makes sense to move the functionality, make it like the behavior encapsulation. You can move the functionality to as close as where you have all the data you need to do the operation and all the knowledge to do the operation. In that weird game that we talked about, where the shuffling algorithm was super specific, even though we have all the data to do that, that weird shuffle is not something that I would probably implement as a part of the deck, or I might inherit it and actually add that functionality to my special game deck or something like that. Where the inheritance is not to add data, but to add data. Right? Does that make sense? Okay? So another one. So can I like shuffle in general? What do you do? How do you shuffle? All right. So let's take a sidebar. Okay. Shuffle. What does shuffle mean?
So be equal probability of card ending up in all. If you cards in all the teams.
All right. So sidebar. So I have a deck of cards, right? And I'm going to, in this case, I'm going to just do this 1, 2, 3, 4. Just a set of numbers. It's not necessarily cards, but that's what I have. So what I'm going to do is I'm going to take the first card and pick a random number between all the cards, including the first one. Yeah? And I'm going to exchange the cards. Yes, so now we do that. Okay? Then I'm done with that. So which means that 1 can be right where it is, or it can be where 2 is, it can be where 3 is, it can be anywhere. Then I pick the second card, and I pick a random card between 1 and 52, again, or 1 and whatever the number is. Again, exchange it. Which means 2 can be either right there, or at 1, or wherever, right? And I go each card one by one, shuffling or substituting it with another card in the deck at some location. One of the probabilities is that I'm exchanging the card with myself, which means I'm not doing anything. Okay? If I did that, if I just go through this loop once with my deck shuffle.
You got one of those cards, you swap it, right? So you got one of those cards in this form. Like, for example, the first form. So if you got the last card in the first form, it doesn't get a chance to.
It will get a chance to go as well. Because the second card I'm shuffling with all the three.
The problem is that some cards have more chances.
Alright. Yeah. Right.
But it's exactly opposite of what your bias is. If I did what you thought I was doing, that is the right shift.
Actually, more.
Okay. So let me repeat what you were thinking, right? So what he was thinking was what I said I was doing was I take the first card, I shuffle with the remaining all the 52. Okay? Then I take the second card, and then I shuffle with the remaining 51, like including 2, but all the way to 51. Then I take 3, and then I exchange with including 3, all the 51. Like the 50 as just 1. This is what you thought, and this is what you had concerns with, and this is the right shuffle. Why? Why? How? Why? This is the right shuffle. This gives you a fair shuffle. What I'm doing is actually the opposite of that, which is intuitively I'm like trying to swap things in and out. They may have exchanged positions in this case. Here I'm actually going all over. So the way to think of it, and you might want to do the math a lot more in detail, and also implement this algorithm. So one of the expectations would be that once I implement this algorithm, the standard Monte Carlo simulation technique, right? You just run this algorithm 100 times, 100,000 times, and then you generate a histogram of what you expect the behavior to be. So if I run this algorithm, right, and then if I do the shuffle, so I start with a deck which starts from 1, goes all the way up to 52, okay, and then I shuffle using this algorithm or this algorithm a million times and generate a million decks, and then I just plot the value of the first card. Ideally speaking, I should have 1 in 52 probability of it being 1, it being 2, it being 3, it being 4. That's what it should be, right? What you see here in this case is essentially a pretty strong bias downwards, which means that this has a greater probability of the numbers which are lower. 1 will be in 1 way more than 152, 152nd. And 52 will be in 1, like way less than 152nd. And you can actually see a very strong trend line. Right? It's a very strong correlation. I mean, if you do this way, you won't see a flat line. You will see like an ups and downs. It's not going to be 152 exactly, but you will see it's more or less within reasons, within the distribution of what you expect from randomization. So do that exercise to convince yourself that yes, don't take my word for it, do it.
I did.
Mm-hmm.
So the concept is right. So you start with the first card, and you swap with
With that or
remaining random. So it's really like a special version of selection sort of thing.
Mm-hmm.
Because you've always got a sorted part of the deck. It's actually a randomized part of the deck.
Mm-hmm.
You keep getting a smaller and smaller non-randomized card, and a bigger and bigger randomized card.
But what I'm having is like now the first card ended up, elsewhere, and we're going to visit that spot again and give it a chance to.
So let me give you the math. That I actually help you with, right? So what is the probability of the first card right now? After I do one swap, what will be the first card?
It could be
any of the 52. And what's the probability of it being any of the 52? 1 in 52? Any chance is any different? The probability of this is 1 in 52, right? Golden. Okay? Second card. Okay? What is the probability that the second card is 2? Remains 2. So it is essentially in the first round, right? If 2 was not touched. If 2 was not touched the first round, okay? Then it's essentially 51 of 52 times 2 will not be touched. Correct? Right? And 1 in 51 times is a good chance that this will not be touched. So this is 1. Okay? And so that's 2, which is essentially why it is 1 by 52 again. Okay? What's the probability of this guy being 1?
It's initially it was
In the first round I swap,
it was 1 by 2.
so that is 1 by 52. In the second round I didn't get swapped. Because if I swapped out again, then I'd get screwed, right? So that would be essentially 51 by 52. Right? That's the probability of it happening. That's 1. And on top of that, 1 could be swapped with this guy, which is let's say 23, and it could be swapped in. Correct? That could happen. What's the probability of that happening? What's the probability of 1 getting swapped with 23? 1 by 52. What's the probability of 23 getting swapped with 21? 23 getting swapped with this guy. It's 1 in 51.
1.
Okay? How many such spots are there?
51.
It will not be 51. It is essentially because if you do 51, then that includes this scenario also. 1 is swapped with any of the 51. Essentially what you're saying is that what I'm swapping with is the same for the first round and the second round, right? That's what you're looking at. There are 51 ways in which that can happen.
Yeah.
And that is essentially, that includes this part. That includes this case. So the first case that we talked about.
No, this part is so you talk about the probability of 1 ending up.
In the second spot.
Yeah. So 1 by 52 is based on the first part.
Correct.
51, but it should be, 50, it can't
1 by 52, sorry. It should be 1 by
1 by.
But this 1 by 51 is actually a part of this. It's a part of this. Right? And when that happens, so that particular scenario is 1 by 50. So you can go mathematically, you can math it out, go mathematically for each step. The probability of any card being any card is 1 by 52. Always. Okay? That's the mathematical way of looking at it. The other way, which is actually, I like that way of looking at it, was essentially saying that what you're saying is that I'm trying to, after my first round, this guy is 1 in 50 to 52 chance of this being a random deck, right? Then I have 51 decks. 51 cards. Now, how do I make sure that that card is randomized? In this, that's essentially to shuffle a full deck. If I randomize the first card appropriately, and then I concatenate a shuffled form of the remaining deck, gives me a fully shuffled deck. Is another way of looking at it. Which is actually.
Would you allow the card to be swapped by itself, with itself, or would you only allow it to swap with cards after? In other words,
Tell me. You tell me.
I did not allow that, but I wondered.
So give me the probability of the first card being 1.
0 if you don't have
0.
So no, it's not a shuffled deck.
Okay, so the odds
The negative case is very easy to prove, right? Because if you don't do that self-shuffle, then 1 will never be in spot 1.
so then it's going to be biased.
It will be totally biased. Right? So you have like a 1 in 50 of the 51 chance of the first card being anything but 1. So that won't work. The problem with these random shuffles is that it's very hard for you to figure out whether it's actually there or not, because I mean it looks shuffled to me. We are good at figuring out patterns, and we are actually also terrible at figuring out whether it's random or not. So I would generally recommend the history of figuring out and again pick a random location, or you can do it for all the as well if you want to do it. I mean that's just too exhaustive. Pick one, draw the histogram, and see how it goes. The chances of it being the bias will be actually pretty clear. In this particular algorithm, the chances of it being 1 is way more, and the chance of it being 52, the first card being 52 is actually less. So there's a bias towards the card being. Okay. Right? Does that make sense? Alright, sidebar. Let's get back to our deck of cards. I know at this rate we'll probably do only one question. So, which is probably okay. I mean the intention is to actually walk through the motion and the mechanics, and then we actually breeze through the other questions with just the key concepts.
So comparing two cards, property of game, but then most of the time, a lot of games depend on the default comparison, right?
Right.
So should we have a behavior on the deck and then
So two things. One of the things that I heard here first was that if I could have a way of actually just overriding the comparator and pass it as a part of the construct or something like that, and I use the comparator for all my other functions like for shuffle and for everything else.
Shuffle we don't need comparator.
We may. The bias deck that we talked about, right? So instead of inheriting the deck, you could just modify that deck's behavior by allowing it to, like, if I can inject or in-source like a comparator from outside, optionally, then I can just write that comparator in such a way that my shuffling actually can. Then I can handle like arbitrary shuffling. One of the beauties of how this works is that you can just get at it. So that's one. To go back to your question, is that is it a property of the deck to actually tell you which card is bigger than which card, which card is smaller than which card?
No, it's mostly game, but then most of the game require.
Correct, but that's not a property of the deck.
Yes.
It is not a property of the deck. The deck doesn't tell me whether A is bigger than B or B is bigger than A.
No, I think that, yeah, so actually since a lot of game is required the default order, should it's a good idea or not good idea? Because, most of the game, they follow the default. Oh, if it's a trump card, then I will override. Because the game is but otherwise, we follow the normal order.
So the way I'm thinking of it, I appreciate the point. I mean, I think it is something to be thinking of, right? So the thing is that the way I am visualizing it is like I'm looking at a card as just one piece. It's a small piece, right? Oh, by the way, does the shape of the card a property of this? Like, is it a square, circle? Is it a big card, oblong, whatever? Is that a property of the card, deck, or anything? Why? Like the image of the card, like the king with the knife through his head or not, and things like this. Like the image or the ornate ace of spades. Would that be a property of the deck, card, game?
Property of the card.
Is it? Is it? So the reason why I question that is that the way you're trying to encapsulate data is that it should contain anything and everything that has to do with the card that you care about. The fact that it is, it's like, if you play a game of solitaire in Windows or whatever, you could switch the imagery of the deck at any point of time. That doesn't change the default card. The card is ace of spades. The fact that it's ornate or the fact that it's just like an A and like a very small spade symbol or something, because you're looking at a mobile phone versus a web page or like a larger device or something, the ornateness of that card seems like a UI rendering property. So there is data and then there is like visualization.
Okay, absolutely. Yeah. Of course, I thought you meant like whether that's
that should be a part.
So
that's part of the card.
I should have clarified better.
The UI is never. The UI would never. Your game engine should be completely separate from the UI.
The rendering engine is the one that is responsible for rendering an ace of spades, and that in and of itself is probably independently shuffleable or switchable. Because whether you have like an ornate deck or whether you have like a crappy deck or whatever else is something that is entirely independent of the actual game and the gameplay mechanics. So this is data and that is rendering. So the rendering could be a layer on top of this, which is independent. Again, so the question, these are the questions that you should be asking yourself. So the output of the question is not as relevant as the questions themselves. So walk through it. So back to the question that you asked was like, sorry.
Like on that same note, I mean, like I implemented a version of Blackjack using console. Right? So
Yes.
display a card would just be saying king of hearts.
Yeah. You just say K edge, or you will draw the heart, like shape if you have that thing available in your ASCII has
Graphics.
heart.
Yeah, that's true.
Some parts of it.
I didn't. Yeah.
So the ASCII, I think, so when you hit Control C on consoles many times, you would actually see the hearts because
There is a Unicode character.
not just Unicode. ASCII has all the code. So 3 is like Control C is like essentially 3. So I don't know if, depending on how you've seen ASCII characters, the first one is like a smiley face, the second one is a smiley face, 3 is hearts, and then 4, 5, 6, 6 is clubs, and the others like diamonds, and 4 is diamonds, 5 is space. But anyway, so it is there. If you print ASCII value of 5, and you will actually see space. So console does support cards or whatever. Alright, back to the question. So I want to actually make sure I cover your question. So this question was saying that given that almost all decks need an inherent way of comparing, telling me which card is bigger than which card, should I implement that as part of the deck? And the answer for that is?
No, it depends on the game.
Again? It's arguable, yes. But we're having this discussion, so why would we go back to the point that he was making, separation of concerns. Is it the concern of the deck to discriminate between the cards in terms of which is bigger than which? Should we? Like I like the comparator concept because that is the property of the shuffle. The shuffle behaves based on changing a comparator inherently gives you an opportunity to influence the shuffle in a way that makes sense for your game. So rather than implement different variants of the deck, you can just implement a deck that can optionally inject a comparator for shuffle. Fantastic. I love that. Okay.
Isn't shuffle intrinsically
Shuffle is not.
well compared to what you use for mana?
If you're sorting, then we can use
Right, not sorting.
shuffle. We can't use.
Actually, so that would
Are you
be
sure?
But yeah, yes, good. Do you agree?
But why do we use it?
Comparator may not be the answer, but a way of actually influencing the shuffle would be having a way of overriding the shuffle using an injection.
I call it a sort.
Shuffle is a sort.
It's a random sort. But it's intrinsic.
Either way. But shuffle has its own algorithm, which we just walked
It has no like and then you're not
You know what? I think what is it called? It's called the random sort. You know what random sort is? No, you essentially random sort actually has a property that you can shuffle, and you can check if the deck is sorted. If it's not sorted, you shuffle it,
Oh, okay.
and then you check. So one of the ways of sorting a deck, like arranging a deck in order, is like you just toss the deck completely, gather it, check if it's in sorted order. If it's in sorted order, great. If not, go it again. Keep repeating. Right?
And it's only what 52 vector.
Something like that. So about 1 billion years is what it will take to get it. But hey, it works. It's functionally true, accurate, but it's just stupid. Anyway, so that is random sort. All right, come back to the game. So that's why I would actually not. Two things. One was thank you for that quote. I think while the concept of comparator-like thing, comparator influencing sort having something that influences the shuffle is a good idea. I don't think the comparator can directly do it. Can be applied. Thank you for that. I had it wired wrong in my head. And the second one is that the order of the cards is generically not a property of the deck. So I would not want to do that. However, if you had a way to arrange the deck in a sorted order for some reason, if you want to implement a sort in this, then I see a reason to actually inject a comparator. And I don't know of any good reasons why you might want to have a unsort option or like a unshuffle option in terms of a deck. But there are like a few games where you might want to have the deck in a predetermined order, and that I think I'm going back to generate probably can do it. I very rarely use it. And so game helper classes or game utilities that actually help you compare between cards, utilities that actually tell you whether this is the same suit as this or is it the same color as this, things like this, right? Those interpretations should be a function of, I think it should be an independent function, not a function of the playing card or the deck. Right? If at all anything, I would actually have tried to put that as a part of the card itself. Am I superior to this card? But I might, because that's the comparator seems to be like a good function that to put inside the card. But I don't think there is any great value to it. Okay? All right. So. Fantastic question. So, is the deck actually face down, or is the deck face up?
Well, like when you get into blackjack, it depends on the dealer. Sometimes goes one part down, one up. So, but we're further down when we get into player. The relationship between player and dealer matters. The implementation.
Those are all part of the game.
Right.
I don't think it's part of the game.
No, there are decks actually where the face is up.
You deal
face up.
So sometimes most card is face up.
Right.
But I mean, in theory, that is exactly what it is. Even if the whole deck is face up, we can only see the top card. That's the whole intent of those games, right? So essentially, in those games, I would expect the game to take the top card, like peek the top card and make it visible to the user. So I expect it to be a property of the game, not a property of the deck. I didn't know when you asked the question, but these questionings and how we go is what gets us to that answer. Right?
because we're
More likely than not, that's what I think. Yes. That, I think, is now introduced because of that, right? Okay, so now let's
assuming that we're not going to allow access to the way. So.
yeah, assuming that we don't add, so far I haven't seen any need to access the whole thing. This right? Alright, now let's move on to see what data structure would you use to store the. Now that this is what we need, what do you do?
I implemented a hand class, so we think that's specific to the game.
That is a game, that's a function of the game, not a function. So this question says implement a deck. That's the first part. Now implement the blackjack. Like now to implement blackjack, I need a hand, I need this, I need that, I need a dealer, I need more. We'll get to that in immediately after this jump to that, and we'll come to hand class.
We need a function to add cards to the deck. So this card
Uh-huh.
doesn't size.
Is it?
Shuffle means get all the cards. It means reset.
Not necessarily. Shuffle could just be shuffle the deck, the cards that you have. And in the Rummy scenario that I talked about, you shuffle the discard pile with the 5 cards that is remaining, given that you have 6 there. Right? So you're adding the 5 cards and this, and you're shuffling, or in some scenarios, you leave the 5 cards in the same order, you only shuffle the discard pile and concatenate it to the bottom. So there are like, house rules are different in each
I guess
place.
it would be reset too. Reset or something.
That is a part of the construction. So construct would do the reset for me. Because reset is not a good.
You want to reset.
The deck is the cards are gone. The collection does not have the cards anymore. So how do you reset?
Well, yeah, no, but I'm not going to delete them anyway. I'm just going to keep it.
Is that what you would do? We'll come back to that. So let's talk about that behavior. So when I deal a card, what happens? So I have a deck of 52 cards. I dealt a card. Now what happens? What happens to the card? The card, I no longer have the reference to the card, is how I would think of it, because my deck is now only 52 cards. And that card has actually now been transferred to the player, who has now added that to his or her hand. So the card object exists, but the card object is now living as a reference in the player's hand, not as part of the deck. So the deck, now if I want to do a reset deck, there is no good way for the deck to actually maintain a reference to that card, first card again. There's no value in doing that as well. In physical terms, the card exists only one.
No, you're right, but it makes the dealing a whole lot more.
But
Now you have to put a deal. Now you're going to have an array that has 52 slots. You're going to have to null up the slot.
why is it an array? Why is it not a collection or a list?
Why is 52?
Yeah, why is it
If
52?
it's a list.
Yeah, I guess because it's a given that the deck could be any size.
It would be a list.
So it would be a list. It could be an array list, but it could be a kind of a collection.
A list of
So in abstract sense.
So how would you shuffle the
Huh?
How would you shuffle the list though? It's going to be a shuffle list.
Right, but the list is still accessible. We're assuming the list.
Array list is you can index it
Yeah.
if you want to, and it's shuffleable, but it's a linked list of sorts.
Yeah.
Which is what I assume when someone says list. That's what we say.
Yeah. We say list.
Sorry, I meant
So then it's harder to shuffle, but not really over. How will you shuffle a linked list?
Like with the algorithm that you
Talk about the algorithm I gave you actually requires random access. Right? Well, one of the ways to that is would be to essentially identify the. I could shuffle independently. I could shuffle something completely independent, not the cards, but just tell me what the number is. Let me change the question. Right? So let me change. We'll come back to the question. If I were to let's assume that we are actually in a convention where we have expert magicians who know the cards at the back of the hand, right? How would you actually trust them to shuffle? Like if magicians want to play a game of Rummy, right? They're like amazing experts with cards, sleight of hand. They can actually make the ace of spades, the fifth card, sixth card at will, right? If they know the deck, how it starts out with, they can shuffle in a way that looks normal, but then they can just arrange the card deck in any way they choose, right? So how would you shuffle this deck? You can't trust anyone. Like the best way to do it is to actually get somebody else to shuffle it. At the very minimum, the magician will know what the top card is or what the bottom card is. You can keep track of one card of each, right? I don't want to give anybody any advantage. So how would you do it? So again? Change the properties of deck. One of these you could do is I could say, hey, you shuffle first, and then I can take that and say, now you shuffle it because you didn't know what it started with, right? And then go on, and you can do that, right? We could do that. The other, so that's one angle of the game. A different angle of the game was we are essentially we are 8 people, and we want to play duplicate bridge. And duplicate bridge essentially involves shuffling a deck and then cloning the deck. What algorithm that you would use to make sure that nobody has an advantage? Because the guy who's arranging the deck the second time, right, would know exactly where the cards are. So the 8 people who are actually playing the game cannot be doing the arranging, right? We only have 8 people. We don't have the 9th person who can actually do it for you. So how would you do that? So I'm trying to bring the concept of a double blind, right? Somehow make you arrange your cards in a way that actually works. Does that make sense? The question makes sense. The problem statement is like so. And believe it or not, this was a problem statement that we were trying to solve. There were just 8 of us and we wanted to play duplicate bridge. And we wanted to how do you do it? Because anyone who's arranging it, one of the 8 will know what's going on. And since it's duplicate bridge, whether it's the second group or the first group, it's the same set of cards, right? So it doesn't matter. And how would you figure out, how would you actually make this work? So the logic that we came up with was essentially that we would actually we'll shuffle the deck in one order. Step 1, okay, which is independent, and then we would repeat the same shuffle. So it's random order of cards for the second deck as well, but then we would actually put numbers in the back of the card, right? And then we would shuffle the first deck again. Numbers as just posted, which can be removed later. So then we shuffle the first deck again, and then looking at the back of the card, we would just arrange it in the same number sequence as the first one. More convoluted than that. So we did that, and then you take away the post-its. Since it's 2 different people who are involved in the first step and 2 different people involved in the second step, there's absolutely no way they can collude. There's no way for people to know what the deck was. Super weird, but that's an equivalent algorithm I would do here for the question that you asked, where I only shuffle an array independently and then use the shuffled array to go arrange the linked list in a way that makes sense, and that would probably be like a faster way to understand. Okay. It's still not as efficient, and I might actually be better off doing an array list or a collection which actually lets me do that. Sure. Cutting at a random location is a good way to actually randomize the shuffling process to make it more difficult. But these are magicians, so they may know how to cut exactly where they want to cut. So in the magician scenario, I don't think it might work. And the other thing is that it might not give you a perfect shuffle also, because what we thought was a perfect shuffle turned out to be a biased shuffle in the first place. So yeah, where dealers actually know how to
put it like they had like 20 cards at the top of the deck.
Yeah. They can do so. Essentially, I don't know if you've seen a bunch of those, but they have this thing called it's like a second card dealing. It's essentially you can palm the first card and you can just keep dealing out the second card, not the top card, but the second card, and it just looks naturally as if you're dealing the top card. And the motion is exactly the same, but they just like kind of thumb the first card in and they just deal the second card. And with that, they actually, if I know that the first card is the ace of spades and I want you to get it, second card, first card, second card, and nobody will be anywhere. And people know that. And the other way they do is that they kind of they even mark the cards with dice, and you watch with your glasses will tell you which one, so the dealer knows which cards to thumb, and without even looking at the cards. So like so many crazy things that happen. But in any case, let's get back to the world of we will get sidetracked, unfortunately. Sorry.
For the discard deck, discard cards, which we're talking about, because we go for a deck inside a deck, so that we can maintain all discarded cards in the deck. That way, all the properties of the deck as well.
Is a discard file a deck, or is a child of a deck? That's the question you're asking?
No, not a child of a deck.
Encapsulated inside a deck, right? A deck of a deck, or some kind of a child property of a deck.
Yeah.
A child class, child collection.
No, like we have a list node or something like that. It's another list node to just have a pointer to the next one. The same way, our deck can have pointer to another deck, which is nothing but a discarded file in cards. So that way, this discarded file will have like properties like D and shuffle and deal one card.
Is that a property of the deck, or is that a property of the game? A deck in its pure form, we are kind of defining the deck to this behavior. If you want to add that to the behavior of a deck, and you have to make a case for it, like if you're in a design discussion, you have to make a case for why it should be. And if your case is like strong, then probably add. Right now is what I've heard. I don't see enough case for us to think of discard pile or a hand as a case of or as a child class of deck, or besides the fact that it has few cards which are associated together, I don't really see much of a value in having a hand class even related to a deck in any form. Right? There's no concept of shuffling a hand. You don't. So you may do certain games, but that's not. It's usually to if I'm trying to sneak a card from you in some game, you shuffle the deck so that you're not preventing people from taking things like that. But that's more a property of avoiding the physical aspects of the card game. Not really not on a. If it's perfectly insulated, then you don't have to. All right, so let's jump into this. Now we have to answer the question that you asked earlier, which was what is data type for cards?
Are you going to have a property or a method that takes the card, type the card in
Yes, thank you. We talked about it, we just digress. So what do you think? Should you have a method that actually adds a card to it? It may not be a construction. The deck might already be constructed. Now, can I just assemble?
Oh, that would be a
So the Rummy case is that I have a pile of cards, which is a discard pile that has about 20 cards. People have cards in their hands, right? And then I have 5 cards left in the deck. The expectation right now is that you're supposed to take the 20 cards, shuffle them, and add them to the bottom of the deck. That is the behavior that the game Rummy will dictate. And I'm probably making up some rules. Please quote me as a rules expert of Rummy, but pretend that there was a game that does this. Now, there is a case to be made that you need to be able to add a card at the bottom of the deck. There are games where you might have the ability to add something to the top of the deck. Right? You might be able to do that to the top of the deck, which is like a closed deck for others to take. Right? It's not necessarily a discard pile, but it's the top of the deck. I might have a reason to do that. Or I might have a reason to actually shove a card in the middle of the deck, somewhere, at a random location, inject a card at a random location. So would you have an add card thing? I think there are enough games, like Blackjack might not need it, because I don't think Blackjack is like I think you just run through the entire deck. Right? You don't, because I think the game. So how does it work? Then you have 6 decks as far as I know, and then once you're done with all the 6 decks, what do we do? Are you ever done with all the 6 decks?
Well, you end before you get
Normally, right?
There's usually a card that helps you. You don't want to shuffle them. You don't want to run out of cards.
You don't want to run out of cards.
So the dealer puts it in the thing where assuming I'm talking.
Yeah. So essentially somewhere around like the 5 deck mark or something, they're adding up thing saying now there's enough to go, but now we'll reshuffle. Right? You don't reuse the pile of the remaining deck. So you just like discard everything and then start fresh with the 6 pile.
No, you wouldn't want to do that.
That's what you do.
Counting. It doesn't count. It's a continuous shuffle.
No. Let me repeat the. So in a casino, I know when the blackjack game begins for the first time, we start with 6 decks of cards, shuffled, perfectly shuffled, all of them shuffled. Each card has 312 cards, right? 2 times 6 is 12. So 312 cards are perfectly shuffled, and somewhere in the 280 mark or something, they'll put a card to represent that this is it, right? So you don't want to run in the middle, run in the middle of it. Now they keep drawing the card from the top, one at a time. They go all the way up to the 280th card. If the game is not over by then, they continue further, and then somewhere around 290, 295, the game stops. Now what do? Shuffle what? All the cards. So they essentially fresh deck of 6 cards. They collect everything, fresh deck. So they restart from the top.
Correct.
Right? So they don't reuse the remaining 20 cards that is left in the pile. They don't do anything more than that. So that's a fresh deck. So that makes sense. So that's fine.
But you always want to start with the count.
Yeah, you want to start with fresh deck of 312 cards. Fantastic. So aligns with what I was thinking. So that's good. And a game of blackjack, how many cards do you burn through? Number of people, depends on number of people. Assuming there are like 6 people, 7 people playing, everybody goes through what, 5 or 6 cards max. So 5 or 6 cards, 5 or 6 people. That's about 30, 40 cards per game, right?
If you're doing a simple deck, sort of limit
Right. So about 5, 6, so 30 cards per game is what I'm assuming. So if they continue doing that, technically they can get about 9 or 10 games before they. Because sometimes it's just 2 or 3 cards. When you just stay. After you have 3 cards, you probably stay in space. You don't go through all the 3 cards. Unless.
Let's not go to Blackjack.
Unless. Alright.
That's a different.
Alright, let's do that later. So what is the deck? Again, did we get a consensus? So yes, I think I'll add a for Blackjack, I don't think it's necessary. So if the interview question was to be around deck and then moving on to Blackjack, and if they already show their hand, use the metaphor that they're going to go through the Blackjack next, then I would not go as far as adding that at this point because that's sort of irrelevant to the thing. You have to focus on what are the key things that you need and possibly some of the things that are more generic to just let you know, keep it flexible. Alright? Alright, so back to the question. So what data structure? I'm hearing kind of a array list sort of structure so that it helps you with the shuffle and it also helps you with the top card, and clearly the card gets spent. Once you take away a card, the deck actually depletes. Right? That's what we want to do. Okay? Alright, so Blackjack. So let's talk about the game mechanics for Blackjack. Right? So how it works in Blackjack, anyone who does not know what Blackjack is? Yes, no, maybe? Okay, fantastic. Then we'll spend a little bit of time just explaining what it is. So what you have is you have essentially a deck. And a deck contains 6 home decks, which is essentially 312 cards is what you start with. Right? 52 cards times 6, that's what you start with. Right? And then you have a dealer, and then you have essentially player 1, player 2, player 3. Is there a limit to the players that we have? The table prevents you from having like 25 players, and the game is also a lot fun. The players are not playing amongst themselves, but they're all playing against the dealer. Let's pretend there's a casino, right? So the players don't play against each other; they only play against the dealer. Because actually the rules are complicated. There's no other way. Right? It's like
I assume it's a split. Usually, you get to decide. Usually, when you play poker, you say
poker is definitely amongst
Blackjack. Blackjack is a form of poker.
Okay, right?
Another side.
So fantastic. So Blackjack is the way it works is that I think you start with 1 or 2 cards there. So everybody gets 2 cards there, right? And dealer also has 2 cards. Dealer has houses 2. Okay? And then the mechanics is essentially you look at the cards that you. This is a blind, right? Is that a blind?
No, the casino typically the player's cards are one. It depends. Usually, one dealer card down and one up. There is a variation of both dealer cards are up, but the
okay.
So this is a simple case.
The player cards are up, which means everybody you see what the cards are, so you know that. I mean, and since you're not playing amongst yourself, you're not leaking any information, and the dealer does not use the player information to make decisions as well. So there is no benefit to this, and it's actually more fun for spectators because they can. So the cards are dealt up, and the way that the rules are essentially if you get 21, right, as the total of the face value of the 2 cards, and the face value is essentially all the way 2 through 10 have the exact same face value as what's on top. Jack, King, and Queen, I believe, have 10 points each as well. And Ace actually has a score of 1 or 11, depending on, if you can choose to pick whichever one you want, right? And so if you have like an Ace and 10 right at the start, 21, and I believe you're 1 already.
Unless the dealer also
has 21. If you get 21, you win. There's some exception for that. If not, whoever has like the better score wins. At this point, this is the evaluation. But then there's also one more option for you is that you can decide to say I hold my hand as is, or I want to add another card. Okay, and that is because let's assume that you got a 2 and a 3. Sure, I want to add one more card to it because then it can be like a 10, so that gives me 15. Now I can add one more card to it, and guess what? If it's 2, then I got 17. I can add one more card to it if I want. I can keep doing that. If you go over 21, then you've lost.
key card is that's where you make the deal bust.
Yeah. So this is a bust.
Once you bust, you
Yeah. We don't even check what the dealer's cards are. You're done, right? And that's the way it is. So the player chooses to either I think it's called like a hit or stay, or the two things you can do, right? I don't know what the term was, but I think it's like one more card or no, I'm done. And I believe once you say you're done, you're done. You can't change your mind afterwards. Like you can keep saying one more card, stop. And once you stop, then there's like till the dealer can.
in theory, you can't do it.
Surrendering does what?
It's not allowed in casinos.
I assume that just means that you don't lose your.
You don't lose.
You don't, because you bet money to start the game and then you get money if you win. Right? So if you surrender, it's essentially like, stop loss because you know that there is no effective way I'm going to win this.
If you lose.
You end up. That's just a
Casino.
And here on the dealer side, the dealer also has the exact same rule logic as like hit or stay. But when to hit and when to stay, I believe the rules, there are like very strict rules governing. Because I believe it's like 15.
On hard hands, it's very strict. On soft hands,
What is the soft hand?
a soft hand is the one hand with ace. Soft hand, the dealer always hits on 16 and lower. Dealer always stands on hard 16 or lower. Always hits on hard 17 or higher. The dealer always stands. It's the dealer always stands. Now, for soft hands, 19, 20, and 21, the dealer always stands. And the base is usually what is most favorable. So for, and it's usual for 16 and lower, the dealer always has. So
Simple set of rules, mathematical rules, Wikipedia will
17 and 18 is very strict. Depends on the casino. Whether the dealer has
The rules are up front.
They're always up front.
So
It's
the
not
how
the
the
dealer's
game is played is actually it's up front, right? So so any questions on the game? None. Your decision is because since if you choose to eat a card because it's a hit, that card is now not in the deck anymore. So that's the only interplay between you and your peers is because if you are counting cards, the probability of getting a 2 is something, the probability of getting a 3 is something, and that probability is affected by not only the fact that you took a card away from before I am playing, but it also depends on what happened in the previous games, right? Because there are 312 cards. In a typical game, you burn through somewhere between 20 to 40 cards. Once you've burnt those 40 cards, I know exactly which 40 cards went up. So if I could somehow mathematically compute what is there in the deck and what is shuffled in the card, right? I could have instead of actually assuming total probability of equal probabilities of 1 in 52 chance of getting an ace or a king or a queen or whatever, I could actually modify the probability to be what is actually in the deck. And that changes a little. So if you card count, that's where it
If we continue a shuffle, they're doing like a continuous shuffle where you can't
For every game they shuffle.
No, they don't shuffle every game, but you can't really tell.
What is the continuity?
It's like they put you can't tell what Yes, you can play, but the rules are the same.
You're just playing for two people, more or less. And there's no interplay between player and player. You just you're playing more money and putting more money at the same time, but you're playing against the same
Right, I
person.
suppose it's very split too.
Yeah, you could actually choose to hit one and not the other one. And
You can also split. You can also, you can flip it. You can split on
these are just different ways of actually. But fair enough. So high level,
Splitting does
high level. This is the game rules. Any concerns?
So when the dealer give the card, the player doesn't know each other's card.
It doesn't matter because the players are all independently. You only play against the dealer. You're not
But
playing-
how can you count card? You need to know what card.
It's all face up.
So they all know.
They all it's face up because it's just more fun that way,
So
right? And-
whatever dealer you is that they all know the card.
Yeah. Whatever card I give her, everybody sees. Cards are giving him, everybody sees. Cards are giving him, everybody sees. So
Eventually, you see that.
you you see most of all the cards depending on the trade shows.
Eventually you do. Eventually you do.
Can we split the middle of the game? Like,
What is split?
whatever
Assume no, and for simplicity purposes, even though it's multiple players, I'm going to say let's keep it simple. One dealer, one player. That's it, right? And the game mechanics are like so: 2 cards dead to the dealer, 2 cards dead to the player, right? And then the dealer has some rule or logic that actually tells you whether you're going to hit or play. You get a chance to do that. You do that first, and then the dealer does it. Right? So you say, I want to stay or I want to hit, and you say you want to hit. The dealer uses the rules to decide to stay or hit. And then the player decides to stay or hit. Then the dealer uses the rules to hit, stay or hit. I mean, if you say the previous time, it continues to stay. Then the player says stay, then you look at that anyway. You see the and that's about it. You know what it is, right? If you already see that the dealer's hands are greater than yours, you'd be stupid to stay.
So you only see one dealer card first.
Yeah, you only see one dealer card, so you can only guess. So essentially, one card is hidden and only one card is visible. So that way you can only guess. Like if that were to be true, because there's a lot of variations that are possible now, so you might want to play a little bit more.
There are no strategies.
The different angles are what would you do if the visible card is like a 2, 3, or 4, and the visible card is a king or a queen, because that changes the probability. And the thing is that if you stay at a lower number, and the dealer goes bust. A bust is essentially when it's greater than 21, then you win. But if you kind of try to maximize your score and you overshoot your thing because you got a 10 when you're like already at a 14, then you're a bust. And even if you're a bust, the dealer actually stops the game right there. So you don't even see whether the dealer is busted.
as a part of the game, is the play like 1-to-1?
So I believe the player plays first, the dealer plays second.
Yes. Oh.
It's a play. Eventually, the bet would be
The bet is actually, I think it's win or lose. So you,
Yes.
I think I believe it's like it's not half.
You bet at the start of the hand. In this game, blackjack, you can change the
And you get the payout is like
1-to-1 unless you get blackjack.
so you get 2x. Like if I put in like 100 chips, I get 200 chips back. Obviously, because if I get 100 back, what's the point of playing?
Oh, right. You keep your 100. Right.
You keep your 100, you also get an additional 100.
Right, and then you get 150.
If you get 150 back, so you get 250 back in total. Essentially, you
Right.
pitch in 100, you get back 200 if you win. You pitch in 100 and you get back 150, 250 if you get a blackjack. Blackjack 21 is exactly.
Keep your
You keep your money and get like 1.5.
or you lose.
Or you lose your entire game. Okay?
So there's a push to it. Right? So whoever has the higher number wins.
Yes. When both of them have stayed and both of them have stayed below 21, or whoever actually has a higher number wins, what happens when it's a draw?
It's a push.
What is a push?
You just keep.
You just keep your money. It's like it's a tie and you keep your 100. Okay. And you don't see that there's a hidden dealer card, so that actually gives you that there's a little bit of like a guessing game in it.
There is a variation, like I said, where both dealer cards are up.
So then there's no guessing.
There's no guessing. So the dealers are ties or favorable
Yeah, because there's more visibility, more.
I've heard about it, I've never actually seen it.
So, any questions on the game?
So for the player, if more than one player doesn't get one win, they all get the dealer, right? So the money either goes to dealer or to the player. They don't get each other.
That is correct. They don't get each other's money. The game is just between the player and the dealer, and it's just optimization that they have like 6 games going in one. So that's
And
about it.
players do all this stuff.
Yeah.
Player coach says everything, the next player coach says everything.
I see. So the player stay hit,
Right.
stay hit.
Yeah, by the time the next player starts, he's completely
So then I stand corrected because I was actually looking at player playing one move and then the dealer
No.
playing one move. That's not because the player does everything and then the dealer does everything. If the player goes bust, then the dealer does nothing. Right?
Yeah, usually.
That's what happens.
But
All
you say that they asked the dealer to hit and then the whole game is smacked them because it was a wrong card or something.
Yes.
I don't understand why that is the case. That it doesn't depend.
I'll explain. Well,
This relevant to the object oriented?
No. But I can explain it.
Let's do that. So this is the interplay. Thank you for actually keeping us on. All right. So now that this is the game, so it's a fun game to play, as long as you're not playing with a lot of money. It's definitely an interesting game. So what I would recommend is so let's stick to the game. So now that let's keep the game simple. One player, one dealer. Player actually chooses to play hit, stay and hit as the case may be. Then the dealer actually does the same stay or hit thing based on this the rule mechanics that we talked about earlier, like soft hand, hard hand, whatever else. Now, how would you actually? What other additional classes will you define on top of abstract card? And so now we need a hand. I'm going to get rid of. Okay. All right. So we define a hand. What is?
Okay. Yeah. Abstract first. Abstract player.
It's just 1 and 1. Let's assume it's just 1 and 1. We still have a person like a dealer and a player.
It can be,
So I'm going to call it a player, which could be like a human player versus a dealer, abstract player. Let's go with it. I'll come back. No bad choices. These are all like design discussions, and we'll come back to what else?
Game.
You actually have a game which is mostly a game engine.
That's where you start.
Yeah.
So the thing to again, I'll repeat one thing I said earlier, was that we are talking about behavior and we are talking about data. Right? These are the two key elements that we're trying to make sure that the right data is actually kept with the right party or right entity, and the right behavior is ascribed with the right entity. That's all. That's the key of object-oriented programming, is just that using inheritance, abstraction, the polymorphism. That's what we're trying to get, right? And then calculation. So, what else? So the score calculation happens here. The brains of the dealer, like what the dealer does. If I were to not have a player class, then I would put it in the game itself, because that's kind of like a simple thing. I don't have to do it. If I do it, then I put it in the game class, right? And then if I were to think of having things like a player AI. So if I were to figure out I want to write an AI engine to play the Blackjack game, then I would write a player class. That's what would be an AI player versus a human. I might still need a player class and a dealer class for that particular reason, because then I can just put the dealer rules in the dealer class, the AI for the player in the player class, and then I can do a bunch of other things there. So it's good to have that, but it may not be necessary depending on what the actual construct will do. Right? What else?
Why would they put the score in the game class? Like I thought the game was as a play instance. Mm-hmm. So you win or you lose.
Mm-hmm. The scoring, right?
Yeah.
So where would scoring be?
I didn't know, maybe a class by itself.
Yeah. Is the score a function of the hand, or is the score a function of the game?
So the game decides the value of the card, and the hand is aware of the total.
Why should the game decide? The hand can decide. The hand is very specific to the blackjack hand.
Okay, no, but the thing is that the value of each card is decided by the game.
Why? I know what he's saying, but why? Why do you think the value of the card should be a game decision and not a hand decision? Why would you not empower the hand to decide what the thing is? Like the thing here is that the ace can either be coded as 11 or a 1, right? Whichever is favorable. Which means like if you have an ace and a 10, then ace is 11, period. Right? Or if you have an ace of 6 and a 4, right? Then ace is 11.
Not necessarily.
What?
You can't double down.
Depending on the rules. So the way I have seen it, and maybe let's keep it simple for this purpose, is that there are some rules that dictate whether ace is 11 or a 1, and in many scenarios, you just assume that it's just favorable. So if by considering ace as 11, if you're going bust, then you would consider ace as 1. That's like the easiest way of actually thinking, right? So if your hand already has like a 6 and a 5 and an ace, then ace is only 1, not 11. Because if you put 11, it busts, right? So you don't want to do that. So the hand, by looking at the cards in there, the rules of what the value of the hand is something that the hand can determine always. Well, we're playing blackjack, so that is correct. So
The hand has
because hand, I think this is a good place to actually bring another layer of encapsulation, saying I will have an abstract hand which contains certain properties, and I will have a blackjack hand certainly which implements a certain property, right? So an abstract hand will essentially what is an abstract hand? It's just a collection of cards, or a bunch of cards. Because there is, I'm kind of using the word bunch because I don't want to influence our thought process of whether it's a card, list, stack, or queue. It's still a bunch of cards. It could be a linked list of cards because I don't care, because it's just one. I don't do much with it. There's not much to do there. Okay? And what else do you need for the hand? I just need to have a way of actually adding a card to the hand. In this case.
And discarding card? Discarding card as well? Discarding a card from the collection?
In an abstract hand, you might want to think of it, but in a blackjack, there is no discard.
Oh, yeah. Right.
So in a blackjack, there is no discard. So which means that now the question is, why would you implement discard up here, and then in the child class, you would say not implemented or not possible or not needed, right? I mean, you would. So one of the ways of doing it is that you define it in the abstract hand. You say, here's how I can add a card, here's how I can discard a card. And then in the child class, like a blackjack hand, where a discard is not possible, you would like add something like an illegal move, invalid except something, you throw an exception.
But the same logic goes with adding a card to the hand. Maybe in another game, you can't add like another card to your hands.
Fair enough. Absolutely. So the adding, that would be the question that would be next. Essentially, is adding a card a property of the hand, or like a function of the hand, or is it a function of the blackjack? There's a question to ask, and which is what?
Blackjack.
So in a game of bridge, for example, you start with a deck of 13 cards, like a hand of 13 cards. You don't add cards or hand after that.
Yeah.
You only keep discarding hands. That's it. There's no add. Right? So there are games where you discard but you never add. There are games where you add, like blackjack, but you never discard. So it doesn't make sense for either of them to be at this level.
Yeah. Also, you need to add a behavior to this. Like for external entities, adding a behavior to
Why would you want to have an abstract hand in the first place?
I'm not saying that. I'm saying that whatever hand is an entity, the behaviors that it's going to impart within a game, maybe something that they added to the hand.
So the hand, if I want to hear you right, you're saying that there is additional behavior that the hand will start showing or demonstrating, and that is something that is added to the hand as a part of the game. It's a function of the game. Is what we look at. Fair enough, possibly. In which case, the hand is nothing but a bunch of cards, and you're just exposing the hand as is, and the game can choose to add, or delete, exchange, reshuffle, do whatever it wants to do. That is one of the ways of doing it.
The way that we have decided what are the interface methods.
So repeat it.
So if you have this flexibility to add behavior to a function, then it takes away the decision you have to take on the different methods.
But then also makes it harder for you to. So you can't have an abstract action, which will be determined later, because in that case you will be exposing your data entities almost public, right? And that's what we want to avoid. That is a decision making mode. So the question was that can I actually defer the action with the behavior thing to later? What if I actually dream of another scenario that I do something else with the hand? And what if I can actually implement the action later and then at a later point of time? So the game can modify the hand's behavior in some shape or form later. Or one of the logical ways to do that would be to expose the data entities of hand in some meaningful ways, which actually will go against the principle of encapsulation. So it could be a clever way of doing certain things, but I would generally stay away from it. But I like your question. So I think that the hand having one or more cards seems to be logical.
At this point, does it make sense to abstract the bunch of cards in the hand? First place?
Does it make sense?
I'm asking.
Yes, no, I mean, I need opinions.
Yes,
So,
because,
tell me.
yes, because otherwise you were
Well, I mean,
Like it's only one property.
is there value to that
It actually has
abstraction?
more
Because,
properties.
because here you're doing blackjack hand is what you want to build. So I'm like, why have an Uber hand with just
Oh, yeah,
this
I don't know,
and then
yeah,
a child
I
like
don't
that? So instead of this, if I were to just call this, there is no hand, there's just a blackjack hand.
So you're going to have a way to get the list of cards. Either you're going to have to expose the cards or have a way to get the cards. It's like your display is going to display it somehow. Your UI code, you have a way to get the information. So, one where
You have to expose a bunch of cards anyways because I have to show it.
Yeah.
I have to show the hand anyways. That is one. No, but the point that was being asked was add card would be a function of the blackjack hand. The question was, do you actually need an abstract hand class which actually supersedes the parent of this? I don't see any significant value. I mean, if at all anything, I can think of a hand having a bunch of cards at that level, and then the behavior of encapsulated by the blackjack hand. But then when I create a concrete instance of the class of the blackjack hand, the game actually cannot operate on the hand. The game has to operate on the blackjack hand. Right? Because the game has to know that it is a blackjack hand. It has to be a blackjack hand, cannot be an abstract hand. However, the UI class that is displaying it can possibly know how to display an abstract hand.
Okay.
And the UI only needs a bunch of cards to display. So if I have a generic game rendering engine which knows how to display hands, then I might want to have a hand because then it doesn't have to have the awareness. It doesn't need to know how to show a blackjack. It's kind of how I'm thinking. But the counter argument to argue the other side is that but every rendering is different. Like a blackjack game, the tables are different, the deal is different, you show different UI elements. So the UI element is so specific to blackjack anyways, you might as well make it, render a blackjack hand today. So pros and cons. I think given that the question is only blackjack, let's not overcomplicate it. Let's go with blackjack hand. Today is, I think, would be a good starting. But if you're a gaming company, a mobile game manufacturing company, and what you're trying to do is trying to build apps which are across multiple things, then you might have a case to have it as an abstract hand, then build a rendering engine for the abstract hand, so that you can just use it as one library that is replicated across all your games. So you may have a case for it. Again, it is very situational. But here, given where we are, let's go with blackjack. So we talked about data. Do you need any other data apart from bunch of cards? Is score a data element of the hand, or is it a function of hand?
What do you mean by score?
What's the hand?
The score of the game or the score of the
Oh,
cards?
the hand score. The hand, what is the hand score? 10 plus 3 plus 2 plus 2. The hand
Okay.
score. Total.
Yeah. They yeah, hand total makes more sense.
It is a hand total. So don't call it a score. Right? When people said score, they meant the hand total. But is the hand total a function or is that a data element?
No.
Function. Why would you store it? Yeah.
Well, you have to check against that.
That's
not expensive
The purpose
to
is to actually, the question is the purpose, not the actual answer. But let's actually break apart why it is. Why is it a function or a so let's start with the question. What do you think? Is it a
Function,
property
you can
or
do
a
one
function?
or 1 or 11. You have that case where you have to, the hand has to know what its count is, and you have to know whether you're flipping from 1 or 11.
So when I add a card to the hand, do I deterministically know what the score, what the hand total changes to?
Yeah, it's part of the hand.
So I know that, right?
Yeah.
So can I not, as a part of add card method, can I not compute the new hand property, the hand total, and just set that value?
You could, yeah.
Just as I add a card to the hand, can I not deterministically compute the value and store it in this property?
Yeah.
So why is it a property and not a function? Why is it a function, not a property? Hence, that is the question that we're trying to answer. One second.
It cannot be a data value because we have the case.
But that you know that at the time of adding a card, right? As to what the value is.
But in that case, we have to store two possible.
Yes, it has to be more.
So first time we already stored yes as a certain. Again, you are getting different value based on that your class should change, right? We cannot simply add that as it is, right?
You would have to have, yes, the point is you do have to have more than one possible. Right? If you have an ace and a 3, that could either be 4 or 14, depending on.
It is 14. Why is it 4?
But then next card will be a 8.
Then that will change the that will change the behavior. That is fine. So all I'm saying is that at any point of time, if I look at my hand,
I agree. Yeah, you could definitely you can calculate it.
Thinking of it, so again, I'm trying to argue in favor of property at this point, right? So when I do that, if I have an ace and a 4, what is my hand total? It is 15. Period.
Not necessarily, or 5.
It is 15. 15 is better than 5. So if I'm actually if I said stay at this point of time, what are you going to use my number as? 15, right?
So what if you decide to go and you overshot, then does it change after that?
Yes.
Because at that time when I add a new card, I know exactly what my hand looks like. So if my hand is ace, 4 and 10, then it's still 15 or whatever, like 9, right? Then it's 14.
The problem comes up when, like I was talking about the dealer blocking markets, then you start to run into problems.
So regardless of whatever the mechanism that you have for this, my assumption is that the hand total only depends on what is in my hand.
Yes. Right. Always.
And the house rules. Whatever the house
No,
rules are.
you're absolutely right. It always only depends on what you have.
So if that is the case, when I add a new card, if there are multiple computations that is possible, if I have an ace, this is either a 15 or like 14 or 24, right? That's what this is. It is clearly not 24.
Yes, not 24. But
it's clearly 14.
The problem is you have to, if the UI wants to show the hand total, and you return only 14, players would be confused because they're going to say, hey, wait a minute, I have 4 or 4. So that's where you have to have
Okay? That makes sense? So that is a good case for making it a function. But even then, there's a bunch of properties that we need to have, and what you return is not one value.
Correct.
But it's complicated because when you add a card, you can calculate it. And when you want to edit it, you will not repeat the way you can get it. If it's function, then every time you want to set the value, you can repeat the calculation.
So let me go back to the question. Is that so in this particular scenario, the list of possible hand totals is this. If I had 2 aces and a 4 or something like that, then I could either consider this as 6, I could consider this as 15 and 16, and I could consider this as 26, right? I could pick all the 3. These are 3 possible values because I have 2 aces. Right? So now, a question back to you, then score is not an integer value. The hand total is essentially a collection of integer values. You can do one of these 3. And you might want to figure out which ones are actually, ineffective, and you might want to say, I don't want to even show 26. So I might want to show 26.
Right, there is a case where you can show 26, there's a case where you don't.
But you can make an assumption that saying my score is just going to be. Now, given that thing, so now I think we picked apart single value versus multiple value. So that is clear. Okay. Now that we are saying it's multiple values, would you want to implement get possible hand totals as a function or as a property? Because I can deterministically figure out what the possible hand totals are as a part of adding a card.
Assuming it's not expensive, I don't think I mean, you probably have to.
You'll have to compute the hand as a part of adding the total, adding a new card. The only time you need to do it. That's the only event when the hand changes. So would you or would you not?
I think I'd wait I'd make it a function.
Deficit impacts the player's decision for add card.
So once the card the hand doesn't change till you add a card. Once you add a card, you take the card, you put it inside a bunch of cards, and then the fact that I put it into a bunch of cards, I can just go amend my total, right? And the logic to amend the total is also fairly simple because I have to go to each one of these totals and just add the face value of the card that I have. That's about it. And ace has a slightly separate handling, but that's about it. So I can easily make a case of why this could be because it's deterministic, it is simple. The other way of looking at it is that I can actually make it into a function, into a property, because it actually helps me compute this. And anyway, you have to create a function to compute. The question is, are you trying to call that function every time the user is asking you, or are you calling the function every time the card is automatically added and caching the result? That's the only question you have.
You could end up, you're not going to probably cache it. In theory, the ultimate thing would be to cache it when it's first asked for.
You are caching it, you do it as a property.
Right, that's true, but you have to compute it.
when you add a card is when the
Right,
when the
but
hand
upfront,
changes.
by upfront, I meant you may not even need it, but you still kind of a good rule of thumb is don't compute it. I mean,
So
it might be
these are all the
might be so simple that who cares?
So this particular scenario, if I were to build this as a mobile app, I would go with either, and I wouldn't really bat an eye. My recommendation here is that I would have to build the get score function anyways, right? Because that's what I will call from the add function. My bias is to just expose that get score function and forget about actually additional data storage. The computation is so insignificant. Like I'm going to go inspect all the cards that I have and just go make this thing happen. It's so insignificant that it doesn't really make too much of a sense for me to cache that value. So I would, in my opinion, I would go with this. But again, we just talked about all the reasons why we can make a case for it. Right? So done. Is there any other thing that you want in the hand?
I want the idea of you not only should you have a list of totals, you can have a best total.
Mm-hmm. Yeah.
There are cases where you need to know exactly what the best total is going to be something, because you have to be, the dealer has to know what to do.
Yeah, we do. So we need to know what the best total is because then that's the only thing you compare.
And that's what that's how the dealer decides.
I might add a method there, is bust.
Is bust. If your best total is
Yeah, but like, why would you implement it outside the hand?
so in the is bust, is that a function of the game
No,
or is it a function of the hand?
Hand. Why?
Because
Why would you
if
put it
my
in the game?
best total in my hand, so the way it is that you're going to compare the hand totals, right? And if my hand total is already greater than 21, so if my best total is greater than 21, here's a bust.
Yeah.
And that knowledge can be built within the UI. That knowledge can be built within the game engine when it's just a comparison. I'm just trying to make an argument against what you just said.
okay,
I'm not convinced. So you need to convince me, saying no, this is why, right? Go for it. Why do you think we should? Why do you think is bust function? Or is blackjack?
Just
Would you build a is blackjack
redundancy.
function? Blackjack implies that the best score is 21. Right?
I don't think I do either. I have like,
So let me explain the question that I'm asking, right? So is blackjack is when your best total equals 21 is blackjack.
Yeah.
Is bust is when your best total is greater than 21.
Yeah.
Right? And is active or is still in play or something is the third scenario where the best total is still less than this.
it's also blackjack.
Or is it just? It's not always?
When you go out to 21, it's not blackjack.
Oh. Okay. So that means if those cards get me blackjack, it's always
So you have to kind of do your game and
Thank you. So there's some slight nuance where it's blackjack. So where I was going with that was those functions, are they helpful? Are they a function of the game or are they a function of the hand? Where would I put it?
You could certainly put it in the hand. You could put it in the hand, but it would be
Oh. So again,
You can
no wrong
find
answers. If I were to be implementing this as a game, I can put it anywhere.
Yeah.
My initial bias, is essentially say not put it with this because it seems like a very specific case. Because what I would like to do is I'd like to get, if I were playing a multiplayer, multi-scenario game, I'd like to go get the scores from everyone and then just figure out in terms of comparison. So one of the advantages that I get is I just use like a simple function that automatically, if there's greater than number, less than that, and that way with just single value, I should be able to compute who won between two players as long as I have their raw scores. The fact that they are bust or not is almost irrelevant to me at that point.
It's relevant if you,
So I would not.
you can know from.
But if you want the UI to actually react to it and make sure different graphic for it, or if you want to, prevent the modification, a player cannot hit anymore after it's bust.
Yeah.
It's a forced state after you bust. So things like this, right? So
out of the game.
you're out of the game with it. You're done. That's it. You're done, and it terminates the game. So my while condition could be that I could say still you're not bust. And for it, right? And not
It's
sure.
like in his blackjack or his bust. Besides the fact you have to calculate, you're going to have to calculate the score. If you have to score it's cash. Each time you call that, you might have to repeat the score again.
Yeah, that's what I would do. I would just do is bust equals score greater than 21 is what I would do.
Right, but you would end up like if you had 2 lines of code where you're checking those 2 conditions, you might end up
So computing my scores twice,
right,
which is, given how inexpensive here, it may not make a difference, but
But you should always be thinking.
we should always be thinking. That's the fair point. That makes sense. Like, the answer is irrelevant. The questions are relevant. So let's talk through the question.
The other problem I have is that since it's redundant, there's a possibility of breaking. And then some clients will check the score to determine if Blackjack. Other clients will call his Blackjack.
And you will have a bug in there is bust at some point of time. In this case, it's so trivial that it might not be the
parts of the game will work and some will not.
Yeah.
So anytime you introduce a redundant upper method, you gotta be very careful. Because I think things can go wrong. If you really want only one way, if I was going to expose that kind of thing, I'd probably not expose the score. So there's just one way.
But there's no way to do
There's
that.
no way to hide it.
But on the other hand, if I'm exposing the hand, like I'm just going to take your argument and kind of like take it to the legal process, right? So since I'm exposing the hand, what prevents some client from computing the score without actually giving a damn about what you think? You are showing the cards. Like I have to expose the cards to you because you're doing the UI, right? What if the UI engine actually says, you know what? I don't care about your scoring thing. I want to compute the score myself from the scratch.
Yeah.
Right, you can't use
That's so cool.
There's no way you can stop.
Yeah.
But then the thing is that the get score is such a great convenience function that is abstracting enough of complexities, right? The aces, non-aces, and all that anybody who's actually even thinking about it is going to look at it and say, hey, it's there, so let me just use it. So if I were to bet that there are like hundreds of clients, I would be surprised if even one client chooses to compute the score on their own when a helper function is already available. However, if I have a is-bust function on 100 clients who are actually trying to do this, the thing to check like if is bust or like hand.isBust or to check if the hand.score is greater than 21 is so trivial in that particular sense that I would not be super surprised if like a handful of clients, like 5 or 6 of them, choose one versus the other. So just taking your argument aside and taking it apart. So I think the focus here is like try to make sure there's only one way of doing it so that you don't have too many variations. But at the same time, it's unavoidable in some circumstances. I would try to not introduce helper functions and convenience methods when the chances of forking is high compared to the convenience offer. The get score convenience offer is actually so high that the fact that there's 2 different ways of doing it, I would bet that I would be surprised if even 1 in 100 clients actually choose to compute it from the ground up. Especially when the get score is so conveniently available. Right? So that's good. Any other mechanism on the get hand? I'm assuming this is all you're doing.
Well, you could have checking. You're going to have a state. See, when I implemented the UI inside, so I have a check hand that does UI, shut down the game. But somehow the game engine is probably going to have to tell the UI the state is.
What does a state mean? That the bust versus blackjack is
Yes.
Why would we need that? Why would the engine not compute it based on score? Just walk through that entire
Right, so
decision
you're
tree.
going to okay, so yeah, you're letting the client do it.
Right? Because the convenience function is not high enough. Would you ever need to reconstruct a hand? Save game, restore game, continue. If you want to do that, right? So you might have a use case of where you're actually dumping the hand, like serialize, deserialize, or some sort of like save game state, retrieve, destruct. So the same thing that we had here, right? The clone part that we talked about might be some use case. Specifically for testing, you might want to actually create a hand, try to say again, what if I have a hand of this, and so on, and things like that, right? So you might want to have one more, and I'm just thinking more from a testability standpoint.
Yeah, otherwise, like 4 hours. Get the case you want.
Something like that. Yeah. Well, you could always like add cards and add specific cards and reconstruct a hand because it's not that hard, right? So since we have add cards, I can add a specific card instead of a random cards, and I can still get there. So I would question whether we need to reconstruct the hand. Like, do you need a reconstruct hand method, or I could just use the add thing and just get the same spot. So I don't know the answer to that. Again, I don't want to debate that here. But that would be a debate as well. In a conversation, you would actually look at this and say, is it required? Is it not required? Can I not do this? Because chances are that if 100 people are trying to do that, like a few will do that mechanism and a few will actually figure out this reconstruct. Because if your reconstruction is hard to do, because you're expecting the data to be, some kind of JSON, some kind of serialized format, and that format is hard to get or not really get documented, it's so much simpler for me to create a hand, erase a space, add 10 of dice, and I'm done, right? I know what a card looks like. So adding 5 cards to a hand is not a big deal. So there's a good case that somebody might do this or that, right? Okay. So let's do. Let's keep time and let's go to the player. What do you think is a player's role here? So so let's do data first and then let's do this next. Data first, behavior next. So data. What would be player's data? Would a player encapsulate a hand? Okay. Single player, single computer, right? Yes, there is a possibility of a more complicated game. You can figure out. Keeping it simple. What else? Money.
Bets.
But because if you do have a UI where you're actually showing how much money you're playing, how much bets you're doing, and whatnot, you need to know how much.
Just a huge amount of stuff. I don't think we want to.
Yeah. So money is like a very basic one that I want to add. And the reason why I bring it up in an interview also is to kind of let the interviewer know that I'm actually thinking about the holistic game thing and not just narrow-minded to what I'm doing. But there's also negative pressure of going overboard with it. So if I actually were to say, what is my player profile, player name, player age, player gender, I mean, I give a picture and all that. You can go to town with